Welcome to Chemical Engineering World. In this video we will discuss about how to repair the common problems of heat exchanger fouling and corrosion. Heat exchange fouling is defined as the accumulation and deposit of unwanted substances that form on the external and internal surfaces of a variety of processing equipment called heat exchangers. This nuisance material can include, but isn't limited to, algae, scale, insoluble salts, and suspended solids. Fact is, in today's industries, fouling can cause major economic drain. Major industry fouling costs for industrialized nations are estimated over $4.4 billion USD. It is estimated that 15% of maintenance costs are attributed by fouling. Next is some heat exchanger costs which are associated with fouling include 1. Production loss associated with efficiency deterioration. 2. Production loss associated with unplanned and planned operation shutdown due to fouling. 3. Maintenance costs from removal of heavy fouling deposits with the use of chemicals. 4. Maintenance costs associated with replacement of plugged equipment. Cleaning costs for industries range between $40,000 to $50,000 per cleaning, per heat exchanger. Now next is effects of fouling on heat exchangers. Fouling and corrosion can cause minor and major problems for the majority of industries who rely on heat exchangers to keep their operation running efficiently. Some major detrimental fouling effects for heat exchange units include loss of transferred heat. This can be seen by the sudden pressure increase and temperature drop in the charge outlet. Under-deposit pollution and corrosion. Blocked process pipes. Where fouling in a heat exchanger has become hot, as in steam generators, it can cause problems with the formation of local hot spots. This can result in the ultimate failure of the equipment. Common types of fouling. Fouling comes in many forms. Some of the most common fouling found in industries include chemical fouling. It is formed when there are chemical changes within the fluid. These changes cause a layer of fouling to form onto the surface of the tube equipment. One of the most common examples of chemical fouling is known as scaling. This can be seen in a boiler or kettle, which is caused by the hardening salt deposits onto heating elements. When the salt solubility reduces, it can cause an overall increase in the temperature. This type of fouling can be minimized by maintaining careful control over the temperature of the tube wall that is in contact with the fluid. With the occurrence of this type of fouling, it can only be removed by mechanical descaling or chemical treatment processes. Biological fouling. Biological fouling is generally caused by the overgrowth of different organisms within the fluid. This is then deposited onto the surface area of the heat exchanger. The type of biological fouling is typically influenced by the material choices used. One notable material that can influence the layers of fouling is that of non-ferrous brasses, which are poisonous to some organisms. Corrosion fouling. It occurs when a layer of corrosion materials build up on the inorganic surface area or tubing. This creates a high thermal resistant layer of corrosion. By carefully choosing the construction materials, the effects can be minimized. For example, corrosion-resistant materials, including nickel-based alloys and stainless steel, are now available to manufacturers of heat exchange units. Deposition fouling. It occurs when fluid particles settle onto the inorganic surface area. This is generally seen when the velocity of fluid falls below critical levels. Heat exchanger monitoring. 1. Inlet and outlet temperature for cold fluid. 2. Inlet and outlet temperature for hot fluid. 3. Mass flow rates for both cold and hot fluid. 4. Hot and cold fluid pressure change across the heat exchanger. Heat exchange monitoring tips. To help keep the heat exchange system running effectively, tips are following. 1. Understand all available data associated with pressure, flow, and temperature indicators. 2. Find out and assess what flows, pressures, and temperatures are recorded by operators on their daily routines. 3. Continuously check the pressure, or differential pressure tracking on the shell side or the tube of a heat exchanger can be extremely valuable information. If the differential pressure builds up over a period of time, it means that something is restricting the flow. 4. To record any temperature data information, it is best to utilize a handheld temperature gun. Infrared temperature guns can help you monitor the temperature of the system effectively throughout its operation. Fouling mechanisms and stages. Fouling can easily be divided into a range of different mechanisms and stages. Several fouling mechanisms generally occur at the same time, with each one requiring different techniques when it comes to prevention. These major fouling stages and mechanisms are as follows. 1. Initiation, delay period. This is the period of clean surface area before the fouling accumulates. Relatively small accumulations of fouling can help to improve heat transfer heat. A relatively clean surface area can help give the heat exchanger a negative fouling rate, along with a negative total fouling amount. 2. Particulate fouling and particle formation, flocculation, and aggregation. 3. Mass migration and transport to fouling sites. 4. Phase separation and deposition. 5. Growth, hardening, and aging of fouling. This period sees an increase in the strength of the deposits. It also affects the erosion and removal of fouling. Chemical cleaning of fouling in heat exchanger tubes. Chemical cleaning techniques range dramatically in the chemicals used and the results that are gained. This type of cleaning method also features many advantages which are more beneficial against mechanical repair. These advantages include quicker cleaning process, less labor intensity, access to difficult-to-clean components that mechanical cleaning may struggle to clean. Chemical cleaning solutions provide the opportunity to clean fouling more effectively without the need to dismantle the heat exchanger. Overall, this speeds up the entire process and allows the equipment to get back up and operational in a reduced time. This can help to save time and money associated with taking the system offline for a period of time. Basic chemical cleaning process. The following steps are generally used in the chemical cleaning procedure. 1. Alkaline clean that remove the buildup of organic materials. 2. Rinse. This is generally completed using a high-flow water flusher. This removes any loose debris, along with any remaining residue from chemicals used. 3. Acid cleaning. This is designed to help dissolve and soften the fouling materials more successfully. 4. And rinse. Heat exchanger manufacturing to combat fouling. In the design process of a heat exchanger, fouling is taken into consideration. Generally, when they're constructed, the manufacturer applies different methods of construction to help provide increased heat transfer in certain areas that may be affected by fouling. Fouling tendencies all depend on the heat exchanger type and the fluids which are used. Throughout the designing stage, many manufacturers consider the following to help with minimizing the occurrence and buildup of fouling. Where applicable, allocate more fouling fluid to the tube side. Design the exchanger for a fouling fluid velocity of 3 feet per second on the shell side and 5 feet per second on the tube.